Ladies and gentlemen, we are very happy to welcome you to ENTSO-E's webinar, part of the Business Network for Innovation on Artificial Intelligence and Electricity, Satellite Technologies and Smart Grid. And I'm very happy to present our distinguished speakers. Laurent Schmitt is ENTSO-E's Secretary General since January 2017. And before he was working for GE Electric Grid Solutions, working in Europe, US, and Asia, and being also a member of strategic committees in SIGRE, IEC, EPRI, and the European Smart Cities platform. Our second speaker is Davide Coppola, and so he is working with ESA. I want to stress this here through a memorandum of understanding on new solutions. Davide Coppola has been working at the European Space Agency business applications already since 2007, has a long-standing experience as a project manager and was leading more than 30 projects in various areas, including energy, health, maritime, offshore, safety, security, always with a focus on using the data available through ESA. We have Aidan O'Sullivan. Aidan has an he's a fellow of the Alan Turing Institute, has a degree in electrical engineering, and holds a PhD from the Department of Mathematics in the Imperial College London. He was awarded a Turing Fellowship, the UK's National Centre for AI and Data Research. Currently, he's exactly looking into AI, how to accelerate the transition to a more sustainable energy system. And then we have Antoine Marot, who represents RTE, a member of ENTSO-E here, an engineer in the Research and Development Department. Antoine has graduated from Stanford and was interning Tesla Motors in 2013, joining 1 year later the RTE, Réseau de Transmission Électrique in France, Research and Development Department, and here he's developing the use of AI with machine learning in power system operations. He's now responsible also for research on what's called the Apogee project, where we are seeing the implementation of a vision on AI in fruitful cooperation also with an AI research lab. So I think you have a very distinguished set of speakers to address AI and electricity. I would like to remind you that, of course, you can ask questions in a written manner, and our distinguished speakers and myself and my colleagues from ENTSO-E are going to respond to these questions, and I will moderate in the end a discussion where some of your questions will also be raised directly to the speakers. I would like now to welcome Laurent Schmitt, ENTSO-E Secretary General, to kickstart our webinar. Thank you, Laurent.
Thank you. So I'm going to share a few slides, mostly to introduce the topic we are going to discuss today. Just want to remind first the objective of these sessions, which we have created now 6 months ago, and it's really to foster exchange of ID across ecosystems and across players coming from a different business perspective. Create a bridge between these ecosystems, startups, citizen initiatives, opinion leaders, and we are very happy to have developed this group already up to 130 members, regularly attending our webinars, which includes a wide variety of companies, being large company like GE, Tesla, or even smaller startups or academics and so on. So there is really no selection criteria and so on. We really want to engage every innovator in Europe to help us to construct the future of our system and really cover various strategic topic areas, being storage, dynamic line rating. Today is about space communication and artificial intelligence. As what I've already introduced, the attended, followed on social media, and we are very happy to also look that our webinars, as what we record them, are regularly. So if you want to go back onto what was discussed today, feel free to access these. So the first of what we're going to discuss is potentially space communication for the design of future communication network required for grids. And here really we are very happy to have established this, I would say, business relationship with ESA. And here the idea behind is to recognize that we see our systems turning more and more as one system coordinating various subsystems at the edge of system. In a coherent way. And so it's looking various business opportunity, whether on one side are related to commercial and residential demand response, peak consumption, peak shavings, smart home and factories, connectivity with EV charging stations. So this is about connecting the flexibility at the edge of our systems, as well as basically use cases related to the grid itself, so transmission and distribution applications, basically being able to access areas of the grids which are located more in remote spaces, to be able to receive early warning on possible outages, as well as basically connect sensors from remote locations to be able potentially like to develop new application like dynamic ratings of some assets into these remote areas. But also the third element, which is to enable new market parties to facilitate the market development, and particularly the activities related to virtual power plants, offering flexibility into the systems, and being able to ultimately introduce more intermittent renewable into basically typical application which we are going to further investigate as part of that relationship. Start to together, we have embarked now into a feasibility study. I think we are going to hear about this, and we really want in end of this year to zoom down on typical use cases and application which we feel are appropriate for this type of communication. We are convinced that grid operation and management will require to enlarge the amount of communication network being used to access data across large geographical footprints. Is probably not going to be about a single technology, but a mixture of a portfolio of technology where the space communication will have probably its area of application, particularly related to the connectivity with remote areas, or ensuring backup services of a very secured network. So these are very important use cases for grid operator. As you probably know, grid operator do have to manage a very large number of use cases which are to be maintained even during blackouts, very severe blackout conditions. And of course that push constraints onto communication infrastructure much higher than what we usually face in into non-energy related domains. The first of this webinar, and very much looking forward what we can develop there. The second element is also a very important development which we see happening, I would say, inside sector of our energy domain, where we do see artificial intelligence booming in various types. Looking at the mathematical calculation engine, there are various type of artificial intelligence developing. When we look at the number of papers developing overall in this industry, it is really striking to see the amount of effort and developments largely through these large IT platform application, being Amazon, Google, and so on. And obviously it is and understand how some of these development could be of use for the energy system as well. The committee has started to work out on basically on a prioritization of technology related to digital. So we reuse the format of the hype cycle from Gartner, and we try to develop our own ENTSO-E hype cycle, trying to map what are the most relevant technologies for a grid operator, and overviewing how we see developments happening in these technologies. And we really see into that hype cycle as what has been developed, artificial of this hype cycle, not having entered yet the Death Valley, if I may say, where we start seeing an inflated number of interest, expectation towards that technology, and where it is very interesting to map these technology against, again, a specific business process and use cases where we will try to apply these technologies. So we stay within D and with our members, as within our research and innovation committees, on exactly where we are when it comes to artificial intelligence, what is the state of the art, and for the moment we rather see it being an emerging technology within our community. Only few TSO have started to apply it more in a trial mode. We see, very interestingly, this application being relevant across various number of use cases, whether these are use cases related to integration of new data sources at the boundary of our system, or application onto our own TSO data sources, as well as down to the automation of the grid system. So this is really be across the entire digital application. And for the moment, most of these applications or trials are around artificial intelligence and machine learning. And we have not identified so far not much on cognitive computing or deep learning, but of course we are always very interesting to hear any development in these spaces as well. So where are the opportunities for TSO? Again, we have analyzed this within our innovation hub related to digital inside the research and innovation committee of ENTSO-E, and we really do see a various set of use cases. Some are related to really pure power system operation in relation to better assessing risks, contingencies related to the systems, fault location, how to go beyond traditional N-1 computation, as what we've been historically doing into preventing major network failures, as well as going into better forecasting of generation and load, wind, and flexibility demands into the balancing mechanism. How to improve asset management, and basically a lot goes around image analysis with drone, being able to anticipate when to replace assets and so on, but as well significant development potentially related to market clearing engines and market optimization, where we do see a constant race for improving our market clearing efficiency in terms of speed, number of data to be able to integrate within a shorter time horizon, and going as close as possible to market time units, which are in the scale basically brings flexibility as close as possible to the real-time environment. So that's the overall approach. In that we are in a space where innovation is absolutely key. So we have identified a few of our Horizon 2020 projects implying TSOs, which are trying to use these AI in different ways. And what is very important is because grid operation is very tightly bound to security of the system. It is of utmost importance to start with a trial first before rolling it out as business as usual. And we are here when it comes to artificial intelligence still very much into this innovation and trial phase. So we are here mentioned a few recent projects. So that's what I wanted to for this webinar. Would also like to make a bit of publicity here for our next InnoGrid event, where we are going to really go through all the best practice, best ID progress of our innovation, TSOs and DSOs, and where digital and is going to be really an important element, as well as a coming conference which we are preparing on regional cooperation, as together with RSCs, regional service coordinators, as well as our end of the year conference, which is this year planned for the 10 years of. So again, a lot for the best ideas.
Okay, many thanks, Laurent, and thanks as well for advertising InnoGrid. I recall the dates of this successful TSO-DSO event. We also just published a report on active system management together with the 4 DSO associations. So InnoGrid is the next on 13 and 14 of May, and we have new seats. I'm very happy now to welcome Davide Coppola, the business developer and project manager of our dear partner, the European Space Agency, to elaborate a little what are the space services in energy and what case studies do we have. I also want to give for you, David, and then Antoine, a question that we have seen here from the audience, from Ian Shechtman. Where is today AI used already by the TSOs in day ahead and intraday? Would be nice to have your answer on these two on the go. Davide, the floor is yours.
Thank you for the introduction. Good afternoon. My name is Davide Coppola, and I'm part of the European Space Agency, and I work specifically for a team which is called Business Applications, and I will be explaining a little bit about it in the next over the next slides. So first of all, thank you for the opportunity to join the webinar and to speak about the contribution of space in the energy marketplace, including AI. And basically, this presentation is structured, I would say, in 3 parts. Firstly, I will give you a quick introduction on the European Space Agency, focusing on the business application part. Then I will move into the some example of space technology in the energy marketplace, so to maybe tell you a little bit more about what is already happening in this respect, and then I'll tell you a little bit what is happening next, at least which kind of activities we're going to support, and that will be the end of the presentation. So first of all, for those of you who might not be fully familiar with the European Space Agency, we are an intergovernmental organization with 22 member states, most of them based in Europe. And the purpose or the mandate of the European Space Agency as a whole is to support cooperation amongst European states in space research, technology, and application. That's basically the Article 2 of our convention. How do we do that? We are organized in a number of programs and framework that you see in these slides, from science on the top left part of these slides, which probably remember the Rosetta mission. And we have programs on satellite imagery, so that's Earth observation, in space transportation, in space flight, navigation, probably know Galileo, and last but not least, application. By application, we mean here the utilization of any kind of space technology or space data to establish capabilities that are relevant to the citizens of the world. So in particular, in the scope of the work that is being done by the team and part of the European Space Agency business application, we, in a nutshell, support European companies to develop commercial products that combine space technology of any type, like satellite imagery, satellite navigation, or satellite communication, or even technologies that are being flown in the human space flight missions, and all these to deliver products that can be used by the citizens, or so to say, fulfill a specific market demand. And so just to clear out some doubts, that's not R&D. I mean, we support companies who want to develop something which can become operationally available and commercially available in the short to medium time frame. So we are basically targeting the 2 to 5 years time frame. Through this program, we've been supporting European companies across several domains, and obviously energy is one of those that you see on the right part of this slide, but also we have quite significant number of activities being supported in topics such as agriculture, aviation, education, etc. And the kind of support that we offer to European companies is obviously financial support, because we do have a funding framework that goes from 60,000 euros to millions of euros co-funding that can be offered to the later stage of the development life cycle. We don't only offer financial support, but we also provide technical and business support to companies working through our program. We have a team of about 40 people between the UK and the Netherlands, where I'm based, that can offer companies their support to develop their business plan, for instance. And last but not least, particularly for companies for small size like startup and SMEs, they have the opportunity to brand basically their product using the ESA logo, which gives often quite some credibility as to the reliability of the engineering process that are being used by the companies. Last but not least, we have an extensive network of partnerships and entities we are cooperating with, and the webinar of today is just an example of a cooperation that has been established with the ENTSO-E a couple of months ago. Right, so moving on to some example of what space means in the energy marketplace. We have supported projects across all the verticals that you see in this slide. So you see from standard, I would say, operation and maintenance, grid services, to projects in the area of renewables with a very high number on the wind energy, that's a part of orange, but also solar, etc. And so giving some practical example of what space can do in the area of critical infrastructure monitoring. I started with a little bit of a provocation, because I mean, typically people, when we start speaking about space in the context of energy infrastructure, they wonder, okay, space, why space? Why does space data matter at all? So I mean, and the general very high answer that I can give to this question is just, I mean, a statistic one, or just putting forward some figures. I mean, if you look at the distance from Earth to the Moon, that's about 384,000 kilometers, and the distance of power lines is about 10 million. So I think there is little discussion around the fact that kind of eye from space, which can give some information on the status of electricity grid, could be possibly beneficial. Right, what does it mean more practically? I mean, you can use space data, for instance, to monitor the interference of vegetation to power line infrastructure. So that's an area where several studies and projects have been started and point to some possibilities there, because basically through space data, through satellite imagery, one can get information about the presence and the type of vegetation. And by knowing so and correlating this information with weather forecast data provided by meteorological satellite, one can also predict the growth of vegetation and thus have a kind of early warning or level of risk of vegetation interfering with power lines. So this is something which has been started at length, and we have also some ongoing projects that are looking into this. Another typical example, which is not related in this case to grid, to the operation of grid infrastructure, but to renewable in general terms, is the utilization, for instance, of wind forecasting data provided by meteorological satellite to understand the bankability of offshore wind farm. This is again another area of interest where we see an increasing number of projects being developed on this topic to work along the different phases of offshore wind farm, starting with the design phase, so again trying to answer the question of profitability, and then providing information about, for instance, wind prediction, does energy forecasting up to 24 or 48 hours. These are all kind of projects that we have supported, and with the positive and promising results, I would say. Another area is about monitoring and again providing early warnings for pylon movements and ground displacement. So basically, what we want to avoid is basically this kind of situation, which can lead to, as we all know, to dramatic consequences as to the availability of energy and the stability of energy supply. And again, here, space data can be used in several ways. I mean, there are a number of global navigation system sensors that can be put on the pylons to provide the kind of continuous and real-time monitoring with a level of time accuracy of with the level of spatial accuracies of millimeters, and let's say in near real time. And to complement these, I mean, there are also satellite imagery techniques that are being used to monitor the ground displacement around, so to say, the same infrastructure. And again, together with data from sensors, this gives the full and overall picture on the level of risk of a given area, and that has to be monitored. This is another example that was, so to say, presented before in the previous presentation, and that's an activity which we are just about to start. It's a feasibility study which is implemented in cooperation with several players, and you see also ENTSO-E being part of those. And basically, as a feasibility study, we're looking at technical feasibility and economic viability of space solution, in this case for smart grid and electricity grid maintenance. There are not tremendous updates because we have actually closed the invitation to tender in March 2019, and we are just about to announce to finalize the evaluation, announce basically the companies that have been selected. But basically, just as a few hints of what we are looking at, we're looking at satellite communication in line with what was said before. We are looking also at satellite communication to support IoT and 5G in the next future. We're looking also at the application of satellite imagery, for instance, through AI, to provide early warnings of potential grid outages or predict peaks in energy production and consumption. These are just examples. What's coming? What's coming next? surprisingly enough, or not surprisingly at all, we have also our ambitious plan on artificial intelligence, and we are just about to launch a study which will be implemented as an open competitive tender, looking at application of artificial intelligence and space to deliver commercial products and services. At this link, you'll find basically the description of the call, and we are going to have a webinar next Tuesday, so please feel free to register. And we'll be offering 60,000 euros to companies who want to develop their business case around customer solution and develop their technical feasibility and commercial viability through our financial support. There are several areas of interest that are being targeted by these, and clearly you see that one of those has to do, of course, with the electric utility. And these are just examples of topics we will be looking into through this study. And another topic which I think is of very high interest to all of you and to the audience is another study, a feasibility study, in this case up to 200,000 euros, which will be opened at the end of August 2019, and that's specifically on cybersecurity. So again, the common topic is to look at technical feasibility and economic viability of space-based services for cybersecurity. And we are looking at solutions that combine space data, such as satellite communication, satellite navigation, satellite imagery, and or enhance existing end-to-end cybersecurity systems. One again of the topic that, or the verticals that will be addressed in the study is energy, among the others, as you can see. And again, the focus is targeting the cybersecurity prevention, protection, detection, and response activities. And also here you see that there is definitely an element of artificial intelligence and machine learning, which is part of this study. And at this link, you'll find on the bottom part of this slide some additional information on this planned study. And well, this is my last slide, and with this I want to thank you for your time, and of course ENTSO-E for the opportunity to be with you and present the application of space in this webinar. Thank you.
Thank you, Davide. I'm sure there's a lot of questions. I will keep them for the end. And now I'm happy to invite our next speaker, which is Aidan O'Sullivan, the fellow from the Alan Turing Institute. Aidan, the floor is yours.
Great. Thank you very much, Joanna. Good afternoon, everyone. Thank you very much for the invitation to come and speak. My background is from a more academic perspective. So I work at the UCL University College London Energy Institute, where I run a group in energy and artificial intelligence research, as well as a new master's in energy systems and data science. So training people in a lot of the new techniques that we're seeing and how they can be used in the energy system to promote a more sustainable system. I also have a role at the Alan Turing Institute, as has been mentioned, which is the UK's leading centre for artificial intelligence research. So I do a lot of lecturing, so hopefully today's talk doesn't come across too much as a lecture, but I wanted to talk a bit more about, Laurent has mentioned, hype cycles, and Davide has covered applications. So I just kind of wanted to address, why we're in the middle of a hype cycle, or why this feels like a good time to do artificial intelligence research, and why it's applicable to the energy system. So machine learning has been around for a while. It broadly falls into three different branches. You have supervised learning and unsupervised learning. So these are kind of the classic areas where we've seen a lot of progress in classification and regression, and it's where kind of 90% of the value has been kind of added to the, in terms of applications, has been developed in the last few years. What we're seeing at the moment now is the kind of a resurgence in interest in reinforcement learning, which is an altogether different type of machine learning, which is what we kind of consider artificial intelligence. So it's related to things like skill acquisition and the learning of tasks, and has a lot of different characteristics. So we'll try and talk about those a bit. So as I mentioned, supervised learning, it's kind of defined by a mapping from an input to an output. So you take in lots of labeled data, which are your answers, and then you try and learn the function that maps the behavior you want to the answer you see. So we have a picture of a dog. We want to train an image classifier, so we have to give it lots of labels saying that this is a dog, and then we can do very well in terms of image recognition. However, reinforcement learning is an altogether different kind of problem, and this is where the kind of the boom in the last 2 or 3 years in AI has come from, progress in this area. So you have a different kind of problem set up. You have an environment, you have an agent making decisions, and it gets rewards and it moves into different states. So this is a problem where we're trying to encourage intelligent behavior in complex dynamic environments. So very different from the supervised learning paradigm that we've seen before. So again, just to hammer home what this looks like, we have actions and states. So the state, typically, video games are used a lot as AI training because they're a very well-defined world with a nice reward function, which is your top score. And then you have some actions that you can take to try and maximize that reward. So in that sense, this is how the agent learns how to behave in the correct way and how we get the intelligent behavior that we want to see. So these are some classic reinforcement learning examples. I won't spend too long on them. I'll just run quickly. So this is Lunar Lander, where you're trying to land a spaceship, applicably enough for today with the ESA, and you want to minimize the amount of fuel consumed, and you want to maximize, your landing in the right area. So again, if you were to think of this as a supervised learning problem, it would be very difficult to, map each action left, right in this scenario to a desired outcome. Whereas in terms of learning a general behavior, it's much more intuitive as a reinforcement learning problem. Similarly, this is the hill climb, where you're trying to get as far up a hill as you can, using as little fuel as you can in this car. And the agent ideally learns a strategy of rolling back and forth to maximize momentum without ever being trained. It's just given a reward function which it tries to maximize, and it learns this kind of intuitive, interesting, intelligent behavior in this environment. This is the cart pole, where you're trying to balance a pole upright on a sliding kind of scale. And again, it would just be such a challenge to try and teach the functions through supervised learning to the desired outcome. So as you can see, reinforcement learning allows us to address a different class of problem. And this is kind of what it looks like in terms of an algorithm. We're mapping from states to desired actions to maximize a reward. So we learn over time that if we're in a state where the cart pole is about to fall over, we make a move, and that maximizes our reward by keeping it upright. So this is quite different to what we've seen in terms of machine learning before, but it's also ideally set up for the energy sector. If you think about the problems we have in the energy sector, we're very rarely in a situation where we can say this is good behavior or this is ideal behavior. So we want something that learns dynamically from a very kind of generalized behavior. We don't want to specify do X in every situation. We want to give it a general kind of behavior. So RL, or reinforcement learning, opens up lots of new applications in this area. So it's becoming much more applicable in the energy sector now. We're in kind of a narrow AI space where we can train algorithms for specific tasks and decision making. We don't have general AI, but we have also the potential to exceed human performance. So if we're giving something labeled data, it's inherently limited by those labels. So if we give a classifier an image of a dog that we've incorrectly labeled as a cat, that mistake will perpetuate. And that's why we often see, the need for lots of data to swamp these kind of issues out. So we need data to simulate the environment realistically. As we've seen before, we need a virtual environment in which to train and to learn. And then we need a well-defined reward function, and we need data. So these elements are starting to come together in the energy system. So for example, in terms of applications, we're seeing more data become available through smart meters. We're also seeing reward functions or things like it through time of use tariffs. And then as a example combining all these things, we've got the DeepMind data center example, where reinforcement learning was used to optimize the cooling to reduce energy consumption. And that was a reward function, and these decisions were taken in terms of maximizing the power utilization efficiency. So I'll just briefly now run through some of the research taking place in the Energy and Artificial Intelligence group at UCL. We've collaborated with an energy supplier, Igloo Energy, to deploy a data-driven decision-making platform working at the customer level to kind of enable a new business model. So the idea was to have a supplier that wasn't based on, didn't profit based on volume, much more sustainable, but would rather learn about customers based on their data and try and offer them smart solutions to their energy problems through energy products and services. So it was we had to develop an algorithm that learned over time about the different characteristics of the customer and what was important. So again, very much a reinforcement learning problem where we had to evolve over time our understanding of things. So that was one aspect. The grid has obviously been a core focus, and I'm going to talk a bit about that now. So obviously it's a highly complex system in terms of spatio-temporal interactions and dynamic behavior, as you can see on the right. This is just a visualization of the daily variability in demand that the grid experiences during March, a couple of weeks in March. Then on the left, you have the spatio-temporal complexity. So controlling all these assets, all these different flavors of assets and balancing a portfolio is an ideal application for artificial intelligence. So we've been working on something that we call the Artificial Intelligence System Operator, and the idea is to schedule generation more optimally using reinforcement learning to minimize the cost of imbalance. So again, you see the setup of the problem being one in which there's a clearly defined reward function, and we can take a set of actions rather than a mapping from inputs to outputs. So this is a highly complex nonlinear problem and a stochastic environment, and one that's only going to get more uncertain and more stochastic as renewables penetration increases. So we wanted to take in wind and load forecasts and state of the grid input output, and we want to output a generation schedule based on certain types of assets that we have in the system. So in terms of kind of preliminary results of what we've actually demonstrated, this is this is kind of the AI system in practice in what it's learning. So on the left, you'll see it training, where it makes random decisions over and over again and sees and observes how they do in the simulated environment. On the right-hand side, you have the test, which is the best known schedules at a certain time. So the different colors represent different types of generation. Purple is wind. So we want a system that maximizes the amount of wind in the system, as that will produce the lowest cost of electricity. Blue is base loading gas, and then we have other gas generators in the mix. So what the system learns over time, if I just restart, you'll see at the start there's a loss of load. So the reward function is set up to penalize loss of load heavily, just as the national grid does, with the cost of kind of £6,000 per megawatt hour of lost load. And then it chooses the generation assets to meet the demand as economically as possible. So it learns to minimize startups, it learns to commit base load, and it learns to maximize wind penetration, all from kind of a completely uninformed start. So this is kind of something that we see as a really exciting demonstration of how useful AI can be in the energy sector as something that learns optimal behavior. So we have a feeling that as the level of renewables penetration increases, it becomes a very complex place for humans to make decisions. So we're looking at algorithms that can make decisions in complex spaces much better than humans do in theory. So the types of applications, I'm more keen to demonstrate to people how the AI problem setup works, and then have you kind of think of your own applications. But these are the types of applications we're currently looking at. I'm sure the people on this call can think of many, many more, and we've had some from Davide that are really exciting. But the real innovation that's happened in the last few years is in the type of problems that we can approach now with these advances in AI. So just as a kind of a brief discussion of what we also do. So in the energy sector, we see that there's a skills gap in data science and AI methods moving forward. So we've launched this MSc to cover that and to try and address that. It's the first of its kind. And this is some of the work that the students have put together in terms of visualization of different data, and they learn about neural networks and things like this. But if you're interested in this stuff, you can contact me for more information. But to conclude the talk, which I think I've gone over time, there's been significant progress in AI in reinforcement learning, which is a real game changer in the types of problems we can approach. It also opens up a lot of applications in the energy sector where we don't have this labeled data that supervised learning needs, and it enables new business models to emerge and really change a real paradigm change in terms of the sector for applications in energy. So what we need to enable more of this is more open data and more talent to work with in this space. So thank you very much. Be happy to take any questions and so forth. And if you're interested in more information, please check out these web pages.
Many thanks, Aidan, for this very interesting summary of the state of play, and of course reconfirms also what we see in the 2019 Gartner hype cycle, AI being one of the 10 technologies that are really, Laurent was saying, valley of death. In a way, it's a valley, it's a mountain of death, let's say, that was able to pass this one and is one of the most promising today. Before we start our discussion, I would like to invite now Antoine Marot, who is from the Research and Development Department of RTE, member of ENTSO-E. Antoine, you have the floor.
Yeah, thank you, Joanna, and thank you for the invitation. So let me just, okay, make it full. So can you hear me? It's fine?
Yes, it's fine, Antoine.
Okay. So yeah, I'm pleased today to be here to talk about this project we had since 2014 at RTE.
Antoine, sorry, we cannot see your slides. There's a challenge.
Okay.
Okay.
Is it good or?
Yes, it's working now. Thanks.
Okay.
Fantastic.
I don't see it on my side. Wait a minute. Okay. My screen, sorry. So can you see it right now? It's fine.
Yes.
Oh, yeah, so this is a project that tries to build a new assistant for control room operators. So given the latest web technologies and the recent advances in AI, this is a joint collaboration with INRIA, so the most famous AI research lab in France, and especially with Isabelle Guillon, which is a very famous researcher as well. So I will give you first some context about the project and an overview of the new interface that was designed for this assistant, which is now open source. And then I will focus on how we're trying to make this assistant smart with AI. So let me first begin with one of our great challenges nowadays as a power grid operating company. And it's about rethinking human-machine interfaces. And why is that? So here you have a picture of a control room today in France. So this might be a familiar working environment for you. When you first enter in such a room, it's always quite something, and you feel quite an atmosphere. You can almost feel the beat of the grid, and that's something important is happening here. And then you look at operators, and you see them working on big desks with lots of applications and many, many screens. So this seems quite complex, but also a very congested working environment. And why is that? It's because as the power system's complexity is rising, more software and information is needed. And the easy way to integrate those new tools was to bring one more screen. But if we continue this way, we'll somehow close the loop, and the operator will not be able to leave his desk anymore. So that's not what we want, for sure. But if you ask him if he'd like to use your new application, he might just say no today. No, thank you, I've already enough. And as you know, we're going through an energy transition with new actors, new dynamics and technologies, which are changing the nature of the power system, and the complexity is still rising. So we have a hard time also to build new lines to get more capacity on the grid. So we'll need more advanced software to operate the system closer to its limits, with greater anticipation and reactivity. And so it seems it's time maybe for a little revolution in this working environment. And so to rethink interfaces, maybe the first thing that can come to mind would be this interface from Minority Report, if you know it, as an inspiration, where you see Tom Cruise working with a big screen and navigating through information with fancy hand gestures. But we actually think that new fancy interactions are not the priority. Today will not be of big help for now, and we think this is rather a problem of information and content management. And our actual sources of inspiration are more a personal assistant that helps you plan and give you suggestions about what might be relevant for you to do or of interest to you, as well as the autonomous vehicle, where you don't really drive anymore, no hands on the wheel, except for very atypical situations, but you rather plan your journey and identify points of interest along the way in a navigation mode. So it frees you sometimes to do more interesting things and also to coordinate with others. And now here is the more concrete picture of the whole idea of the project. So you have today a bunch of applications running side by side, and you're working with them in a supervision mode. So they don't really tell you what are your tasks. You somehow need to monitor them and find out if there is some important alarm or information to consider among all of them. And additionally, you need to find some relevant information associated to it through all the other applications. So you eventually have to take a quick decision, but you don't have time to make overall strategies to optimize your operations. And so rather than supervision, we'd like to develop what we call hypervision, whose idea is to refocus operators on their task while bringing them the necessary information to complete those tasks. And whole applications will not disappear. They will just run in the background as a service. So the Apogee assistant can be regarded as kind of a master of puppets. So you use and run proper information and computation in the background to identify tasks. You associate some context and you make some suggestions. And here now you can see a screenshot of the current interface with 3 main windows. So the most important one is a feed of cards on the left. So one card corresponding to a task, which are prioritized from top to bottom. When highlighting a task, you can see its content and what you can do to complete it. And one important thing is that you can easily share your task with others, asking for help, and they will get the same information as you have. So information is flowing kind of seamlessly, and this should help a lot with coordination. And finally, on the top, you can visualize the timeline to keep an eye on your workload over time, as well as all the tasks you already completed and that are pre-configured to run automatically when they will happen. And so really the idea is to switch the operator focus from an alarm monitoring to a task completion, from a driving mode to a navigation mode. And they actually did something very similar for flight cockpits. And this framework is now open source under the Linux Foundation Energy Initiative. So if you're interested in, you can look into it. You can also watch a demo video of the interface and the application running. But now to make this interface very efficient, you actually need some AI running in the background to identify the most important task and associate some relevant content while filtering irrelevant data. So let's take a look on what are those tasks exactly, especially on one of the hardest tasks for a control room operator over its time of operations. He has to anticipate congestions in power lines and implement remedial actions before it's too late and a cascading failure happens. So we want to help him anticipate and assess those risks, make sense of a situation for him to grab the relevant context, and speed up his remedial action search. And this task can be seen as a typical problem-solving and decision-making task, where you first identify the problem, look for solutions, and eventually make a choice. And in more details, so the process today can be decomposed as follows. So on the left, you're given some forecast and a list of contingencies to identify risky situations with a physical simulator. So it's very similar to security analysis. Then operators will study those risky situations, finding possible remedial action from scratch. And when taking a decision, they will validate their candidate solutions with a physical simulator again, and make a trade-off through some criteria to choose one. But there are some limitations actually to solely using physical models today. So they have a lot of qualities, but I'm only focusing here on the limitations. So for instance, for risk assessments in depth, so they have a high computational time. We have a hard time to model uncertainty. They have a high dependence on data availability. And also at the end, after the computations, you have lots of irrelevant information in your results. And when you speak about the quick and deep remedial action search, again, you have a high computational time. You don't have any suggestions over known remedial actions. And again, you have lots of irrelevant information in the results. So physical models, they don't actually use any memory of past operation to screen and filter what is relevant and accelerate computations. And so we think that AI will help us learn from our system operations and complement our physical models. And one key element for us is learning. So I will skip this part because the previous presentation really explained very well those aspects and why machine learning is taking off. And a key catalyst was maybe the advent of deep learning in 2010, because those are very flexible models with a high capacity to learn, and this is really changing the field. But let me now focus on how we see AI and how we actually decompose AI in our projects. So here is what our artificial brain should look like. So AI should actually be regarded as a system with many interacting components that are needed to make it work. So it's not magical for sure. So we represent it as a Lego brain made of those functional bricks. And we don't pretend to replace a human brain for sure. And there are the four main pillars to it for us. So first, it starts with data, which correspond to a bunch of experiences to learn from. So data is the fuel, the food of any AI system today, to build up some memory and get some perception over your environment. So data is really everyone's matter in AI. Then you need to process your data to make it informative, to efficiently learn from it. So you can make some statistics, do some signal processing or filtering, make some nice visualization for your operators, for instance. So you essentially make representations over your data. And this is especially important for our AI system because it needs to dialogue with our human operators. And so this can be seen as a common language between them. So once you have data and proper representations, you can actually learn from your power systems, and you can learn to imitate your operators from past operations in your context. Or you can also learn to imitate the physical simulators and learn the physical laws from it. And finally, as the power system is changing or getting more complex, you need to adapt or reinforce your learning. So we have actually 3 PhD theses over those last 3 pillars. So one just finished and the 2 others started last year. And I will quickly give you 2 illustrations of our works. So the first one, the symbol is a map to actually make some interesting representation of a large power grid. And so coming back to our Apogee interface, we don't want our operators to go back to their study tool looking at the full map of the grid to find one information. So we want to associate to a card, so hence a task, some relevant visualization of the grid. So our goal was to segment the grid into coherent electrical zones in terms of active power, to then identify a relevant area of interest to focus on a task. And so we actually developed a method to segment the grid hierarchically on a given situation using clustering, and we got very interesting interpretable results for our operators. Second application, whose symbol is the net, is about complementing or replacing physical models to compute the load flow. And so we wanted to learn to predict power flows with neural nets to imitate the simulator and see which speed up we could achieve. So the LeapNet here is actually a black box, which actually learns to predict the power flows around nominal conditions of operations, given productions and consumptions as inputs. It can simulate contingencies, but not much more actions. It doesn't need the full description of the topology, just information about any change from nominal operations. And the graph neural solver is closer in spirit to a solver, each layer corresponding to one solver iteration over the graph of the grid. And here is the table for comparison. So you have a trade-off between physical guarantees and accuracy, accounting for conditions of operations, computational speed, and generalization. And so the LeapNet is a lot faster with a good enough accuracy of around 2% compared to the physical models. And this is better than the DC approximation that has over 5% error. And the graph neural net is more an hybrid between physical models and black box. And so those neural nets have been learned using physical model simulators, and they could certainly not be learned without them. So we now have a variety of load flows to choose from for your specific applications, depending on what is the most important property to you. And finally, to connect the dots, so the further you are from the decision, the more you can relax on accuracy to explore a lot. So you can replace your slow physical simulator by your faster neural nets to learn that you learned, while keeping the physical simulator to eventually validate a decision. And so the gain in computational speed and the reuse of knowledge of operation could really leave some time to the operators to define overall strategies rather than instantaneous tactics. And so to summarize, we see AI as a combination of learning, expert knowledge, and physical models to assist our operators and hopefully make this smart personal assistant happen. So thank you for your time.
Many thanks, Antoine, for this very interesting presentation. And it was interesting to see that, like Aidan, you also highlighted the learning needs. Aidan was talking about a skill gap that is to be observed. Yeah, I would like now to start the questions, also building on those questions that we have received. And the first question indeed is, where are we today? What are the TSOs already using? Yeah, and how do you see? So the time, what is the timing needed to deploy these technologies, satellite technologies, artificial intelligence, in order to improve the system operations? That would be my first question. I would like to have everyone respond briefly to that question, starting with Laurent.
Yes, so Sudan, thank you for asking the question. I think it's a good question. While we deploy our new network codes, we definitely see the need for further platform and further complex calculation at the pan-European level, particularly talking about new balancing markets, a new common grid model calculation. And the challenge which we have is definitely to bridge what we can do on short term with what we hear from this Horizon project or this very interesting example of RTE, and while taking benefit of the open source community and so on. So there is a right balance to be found between short-term platform implementation needs and what we discover into the innovation phase.
Okay, Antoine, what are you saying on this? When is it going to be large scale deployed in the TSO community?
So I think one of the great challenge for our operators is to have some interpretability about what the AI assistant can suggest. And so I think AI can be deployed closer to, you know, the data, further away from the decision process. AI first needs to be informative for our operators who are still in charge of the decision. So if they have a black box that is very performant, they will reject it, and that already happened actually at RT. So they need to learn some knowledge on how the system behaves. So really any AI methods that can make informations from data would be very useful and can be deployed quite quickly, I think, for our operators.
Quite quickly means what, 2022?
Yeah, I mean, we're already doing some experimentation, so those are not very, at this point, it's not very critical, you know, it's not interacting with the SCADA, so we have more flexibility to deploy them.
Yeah, sure. No, it's interesting also to think what does it mean for, let's say, the European internal energy market. If some use those new technologies, others don't. Yeah, is that anyhow upsetting the integration efforts that are currently undertaken? But in line with what Laurent said on the network codes. Yeah, what's your take, Davide? Davide, sorry.
Yeah. It's a very good question for which there are, I think, there is no single answer. And when looking at satellite communication, if you think of satellite communication as backhauling or backup, so looking at the resilience kind of things, well, one would say that basically the technology is already there. So maybe the question is about the maturity of the business plan and the business case around it, if that's already not fit for purpose, if that's something that utilities would be prepared to pay for instance. And there, I mean, what is coming next is the implementation of the mega constellation, which will, of course, reduce the cost of the bandwidth. So this is about, if you look at it from a backup perspective. Then there are a number of new trends coming up, as for instance, concerning the integration of satellite into 5G networks, which, of course, is something that will take some time before materializing, or also a number of projects related to IoT. And these, I mean, some embryonic commercial services are already, and some established commercial services are already in place, but there are some new initiatives also leveraging on new technologies that are being deployed as we speak. So in general, my answer to this is that it really depends. There are aspects and solutions that are already available on the market, and on the contrary, there are other solutions that are being developed as we speak that will take a couple of years, 3 to 5 years, before they can be used operationally.
Thank you for that. So quite short term from your perspective, Aidan, are you agreeing with that?
Maybe not. Maybe a bit more negative in terms of my outlook, but just from a UK perspective, I think given that the energy system is such a highly regulated environment, the regulatory bodies need to be aligned with enabling this to happen, to give a push to the TSOs to take it on in terms of whether the incentives are there for them to do it now. Perhaps not. I think there's too much. There's too little to gain in terms of the actual. In terms of the responsibility that would need to be taken in terms of what could be deployed. What we might see is a more staged deployment. So again, referring back to the DeepMind example, to kind of build trust, what they did initially was keep a human in the loop and make artificial intelligence recommendations, and then whether to act on those decisions or not was determined by the operator. So that seemed to be kind of a halfway stage towards full AI control, but I think it's a necessary step to build trust in the system, I think. So we might see a more staged approach of kind of half AI, half human in the loop kind of system.
Yeah, thank you very much. I think it was very important what you said. This, let's say, nexus of innovate twins, the regulated companies, TSOs, but also DSOs, and then the regulators, and they need to move along together. Maybe there's some hope with this provision in the clean energy package that talks about the smart networks indicator, and why not try to push into such regulation the need for using AI as one of the solutions. Yeah? But I would like to come back to another point that you mentioned, Aidan, and that Antoine mentioned as well, the skills gap. Yeah, is there a risk that the regulated companies slash the regulators are simply sidelining these AI opportunities, space-based technologies, and continuing business as usual in order to stay in the comfort zone? Is there a risk of that? Can you start to Aidan?
Yeah, sure. So, I mean, if you were to look at the scale of research funding into artificial intelligence, industrial research funding, the energy sector is not even on the chart in terms of comparison to tech. So, as a sector, we're definitely lagging behind, and it's good to see that we're starting to pick up some slack there. And one of the reasons we are lagging behind is a lack of awareness. Speaking as an electrical engineer who worked in the energy sector for a while, it is very much a engineering dominated sector in terms of the way people approach things, and the solutions that have been developed come from that perspective. Seeing machine learning become an option for people is something we're really keen to promote within the energy sector, and that's why we've set up a new master's to combine those skills together, of understanding the energy systems while also learning about machine learning and what it can do. So hopefully it's something that will change. There seems to be a bit of a wave at the moment of it's starting to gain traction, but as a sector, it's behind finance, it's behind retail, it's behind tech massively in terms of deploying these technologies.
Yeah, that's very interesting. I think it's exactly that. Really skills, but also maybe diversity in a sector that has functioned ever since Tesla, Westinghouse have invented it in a rather continuous way. Yeah, so that's interesting. Someone else wants to react on this question on the skills gap? Maybe Antoine?
Yeah, maybe Susan, I can myself comment as well. I do share the view that there is a skills gap. In the same time, I think we have a particularity in our domain is this famous security of supply and the risk which are related to the action which are taken by dispatchers and some of traders and so on. And I think the technologies, if I may say, and researchers should also sometimes be aware of that and a bit humble in a way. We do see a lot of potential and progress. In the same time, I still wonder whether the engine are already ready to be able to be used in very deterministic short-term real-time environments. When I show my car, which is supposed to have a self-driving engine and one of the most developed of the markets, I still feel very at risk when I drive with the self-driving engine. So we also must realize that these engines are still new, and are they really ready for purpose for these very deterministic control environments?
Yeah, I think this is a very, very good comment. And then it's all about pilots testing and R&D spending. And I think it's quite obvious that let's say the spending, the engagement, but also the programs may be related to these crossing sectors in a way, like you said, on this master that you develop, yeah, are not sufficiently there. And I think there's a common interest to see this more in order to speed the pilots up, while of course, as Laurent was saying, not play around with the system, because we enjoy, different from the US, very high degree of security of supply and continuous power supply, so we cannot, of course, put that at risk. Another point related now to risks, indeed, is cybersecurity. Artificial intelligence, is that generating more cybersecurity risks, Laurent?
So first of all, cybersecurity is definitely a major risk which we need to mitigate in our power system environment as infrastructure of vital interest. And I think the electrical system is by far the most complex and the most potentially impacting system in case of a significant cyber attack. So that is an important element. And we are at ENTSO-E working very hard on setting up, I would say, a very complex cybersecurity strategy in being able to properly handle various levels of confidentiality of data, as well as being able to manage a comprehensive end-to-end cybersecurity across various systems, being a spatial system, being optical fiber, or being internet. So I think the industry has really realized that, and we do see significant development, and artificial intelligence is definitely an interesting tool to be able to detect patterns of attacks and some element of it. But I think that cybersecurity is an important element of the equation, and it has to be dealt with while we these new database and learning algorithm.
Thank you. Someone else wants to respond on this question? Maybe Aidan or Antoine?
Certainly, yeah. So as far as kind of cybersecurity, obviously it's a massively important area. The only kind of comments I'd make would be around cascading failures. The mathematics of cascading failures are extremely complicated, and AI would be something I would see as quite useful in terms of offering alternative, I believe, kill chains is the term used to kind of isolate a blackout or potential blackout that could be used to kind of counteract cybersecurity attacks. Given the complexity of the system we're dealing with, it would seem like this is one potential solution and an area worthy of research, I would imagine. But yeah, that's all I would have to say.
Thank you. Antoine?
Yeah, for sure. I mean, cybersecurity is a very hot topic. We used to operate grids with physical models in mind, but now with cybersecurity, I mean, things can be interacting between France and Poland. So it makes things very, very tough to analyze. But I mean, AI is only another layer. It relies on digitalization, and I think the bottleneck is here. I mean, AI can either help to counterattack, or can also be, I mean, detrimental because it relies on many data and many measurements. So if somehow you have noisy measurements or invalid measurements, at some point it could collapse. But we could develop some new method for more robust AI, and I think typically DeepMind is looking a lot into it. So yes, there is a whole field of research to develop robust AI, and that could help with cybersecurity.
Thank you. I would like to ask a question to Davide. Davide, in a way, we have two topics on today's agenda that are closely linked. Yeah, one is satellite technologies, the other one is AI, ML. Yeah, how are these linked exactly? How would you explain that from your ESA perspective?
Okay, so concerning AI, we're looking at it because there is a big potential there to apply AI techniques to space data to deliver a commercial service, right? So when you look at it, there are companies that might be already doing these kind of applications, like combining even positioning data from Galileo GPS, and there is a big potential there to create commercial services. So we see an opportunity there to encourage European companies to come forward with ideas about space and AI, because there is a big market there that is waiting that could be interested in this kind of solution. And I didn't quite get your second point.
No, this was exactly. So how are they related? Let's say satellite technologies and and machine learning, let's say, and AI. I think you answered that.
Yeah, thank you.
Okay. I would like to close our discussion today, reminding the speakers, of course, that we got a lot of very specific and also general written questions that will be answered by ENTSO-E and by the speakers. I would also like to say that this business network of innovation, as Laurent introduced it in the beginning, is acting in the ecosystem around the research and development work of the TSO community united in ENTSO-E. We very much appreciate proposals from also the audience on those topics they want to see addressed, and will set up a program board in the future. And let me conclude in advertising our InnoGrid event that is done in cooperation this year with the Florence School of Regulation, the already mentioned Linux Foundation, with Insights, with Scient, with ISGAN, with Smart Wires, and the topic of which is connecting physics and digits, exactly in the middle of today's discussion, yeah, power platforms on the rise in Brussels, 13 to 14 of May. And many thanks as well to Joanna Leppels, who has been instrumental to prepare the series of Business Network for Innovation webinars, and also Laurent Decani, who is working in our research team, and he's now supporting this activity that started 1 year ago. Many thanks to all of you. Many thanks to the speakers, and keep in touch for the next event.